Hello, welcome back to the channel, and today I'm going to be going through this intermediate Unit 1 non-calculator WJEC Maths Numeracy paper from May 2023. So this paper consists of 13 questions, and I should point out that usually the second half of the questions on the intermediate paper are the first half of the questions on the higher tier paper that I've already done on this channel. So you may find that I've done these questions before. However, I'll be doing them as if I'm seeing them from scratch. So usual thing about taking pi to be 3.14 using black ink. I'm doing this on a tablet, so some of the questions we may struggle to do just because of using things like compasses and protractors, and also the scale is different. Okay, usual formula sheet with the area of a trapezium and the volume of a prism. And the first question is, in this question you will be assessed on the quality of your organisation, communication and accuracy of writing. And then they've shown us 3 different bottles of different sizes at different price. Caitlin is buying some medicine. Which size bottle of medicine offers the best value for money? You must show all your workings. So we have to be able to do a comparison. So we need to know the price either per milliliter or price per 10 milliliters or price per litre or something like that. So the first thing I'm seeing here is that all of these are a multiple of 10. So first of all, find price per 10 milliliters. So to make the small bottle down to 10 milliliters, we have to divide by 3. So we have to divide 120, so I'm going to do this all in pence because I think when we divide all these by the requisite numbers, we're going to end up in a price of pence. So we're going to divide this by 3. So there are 4 3s in 12, 0. So the small bottle is equal to 40 pence per 10 milliliters. We can now do the same for the second one, which is going to be 4 divided by 156. So the 0, 3, carry the 3, 9. So medium bottle is equal to 39p per 10 milliliters. And finally we got 5, which is dividing 225. So that's a 0, a 4, carry 2, 5. So this is 45p or pence per 10 milliliters. Therefore, the medium bottle is best value. Right. A survey was carried out in the USA. 743 teenagers were interviewed. They were asked what type of information they posted on social media. The results are displayed on the internet as shown below. How many times bigger is the percentage of teenagers who posted about family than the percentage that posted about religious belief? So family is 44%. And to find out how many times bigger, we have to divide by religious beliefs, which is 11%. So 44 divided by 11 is 4 times bigger. What fraction of these teenagers posted about their emotions and feelings? give your answer in simplest form. So emotions and feelings is 34%. So we have 34%, that is equal to 34 over 100. Both are divisible by 2, which would give 17 over 50. And 17 is a prime number, so we can't divide any more. D looks at the type of information posted by these teenagers. What is the modal type of information? So the mode means the most, so which topic was posted about the most, and that was accomplishments at 49%. What information would have to be needed in the original data so that the hypothesis could be tested? In the US, teenage girls posted about their family more often than teenage boys. So you would need to ask a question about gender. So you need to ask gender on each survey. How many of these 443 teenagers posted about religious beliefs? You must show all your workings. So religious beliefs was 11%. So we need to find 11% of 743. So 11% means 11 divided by 100. And of means times, so we need to find 11% of 743. So there's a couple of ways to be able to do this. So we could find 10% first and then find 1%, which might be the easiest way to do this quickly. Or we can times 11 by 473 and divide it by 100, which is the way that I'm going to do it. So 1 times 3 is 3, 1 times 4 is 4, 1 times 7 is 7, add a 0, and then 1 times 3 is 3, 1 times 4 is 4, is 7, and then we sum all of these, so we got 3, 7, 11, carry 1 is 8. So therefore we have 8. This is equal to 8,073 divided by 100, which is equal to 81.73. So I would say 82 people posted about religious beliefs. Lottie is confused by the data in the diagram. She says the diagram can't be right as the bars don't add up to 100%. The diagram is correct. Explain why the bars do not add up to 100%, and because people can post about more than one subject. Right, next up, Hydrodru is a bathroom and plumbing shop, and they sell taps, sets of taps and baths. One day, 80 customers bought one bath and one set of taps, or one bath or one set of taps. The Venn diagram shows the number of customers that bought these items. How many baths did these customers buy? So for baths, 10 customers bought only a bath, and another 40 bought both baths and a set of taps. So this is 10 plus 40 is equal to 50. A bath costs £180, a set of taps costs £60. Calculate the total of the baths and sets of taps bought by these 80 customers. So there's a couple of ways of doing this. The way that I'm going to do it is saying that 50 customers bought baths, so we're going to times that by 180. And we're going to say that 70 customers, because that's 40 plus 30, bought taps at 60. So 5 times 18 is 90, but we've got those two zeros to add on to the end, so that's £9,000 for baths. And we've got 7 times 6, which is 42, add another couple of zeros, so we're going to add all these together, so we get 13,200. Pounds spent on both. Hydro sells pipes and couplings to join pipes. 3 pipes are joined using 2 couplers, as shown below. How many couplers are needed for 6 pipes? So we can see there is 1 less coupling than there are pipes. So in this top example there are 3 pipes but only 2 couplings. So that means that 5 couplings are needed. An equation is used to work out the number of couplings needed to join pipes. P is the number of pipes, C is the number of couplings. Which of the following equations can be used to calculate the number of couplings? So I've already said in the previous question, this must be the number of pipes minus 1. So it's that one. Okay, Alice uses 400 kilowatts of electricity. Electricity is charged at 32p per kilowatt and the standing charge is £62. 5% VAT is payable on all charges. Calculate Alice's electricity bill. You must show all your workings. So first of all, cost of electricity. So this is equal to 400 multiplied by, I'm going to do this in pounds, actually no, I'll do it in pence first, times 32 pence. So for this we can do 4 times 32, which is 8 and 12, and we can add a couple of zeros on the end to take into account this is 400. So it's going to cost what's that? 12,800 pence, which is equal to £128. So to that £128 we have to add 62p. So we've got to so electricity plus the standing charge is equal to 128 plus 62, which is going to give £190. We now have to find 5% of £190. Well, 10% of £190 is £19. Therefore, 5% is half of that, so it's 19 divided by 2, which is 9.5. So total bill is equal to 190 plus 9.5, which is £199.5. Okay, question 5. Lynette is ordering a t-shirt. She wants her initial L printed on the t-shirt. Details of Lynette's design are given below. The height is twice the width and the height is 10 centimetres. So we should add that onto the diagram. And if the height is twice the width, then the width must be 5 centimetres. The cost of printing is 50p for an area of 2 centimetres squared. How much will how much will it cost Lynette to have her design printed on the t-shirt? So we can split this down into two shapes. So I'm going to put a line there. So this is going to be 5 times 2, and this is going to be 8 times 2. So 5 times 2 is equal to 10. 2 times 8 is equal to 16. If we sum those, that comes to 26 centimetres squared. So 50p per 2 centimetres. If we divide by 2, this will give 25p per 1 centimetre squared. So now we have to do 26 times by 25. So 6 times 5 is 0, carry the 3. 5 times 2 is 10, but we got the 3, so that's 130. Add the 0. 2 times 6 is 12, carry the 1. 2 times 2 is 4, but we've also got the 5 as well. So we sum these, so we got 0, 5, 6. So it's going to come to £6.50 cost. A survey is carried out to find out how often primary school children play board games. A questionnaire was designed for the primary school children to answer. The following two questions were asked. Do you live in 5 minutes walking distance of the school? How often do you play board games? For each question, give one reason why it is not suitable. So I'm assuming this is why the question is not suitable. So, do you live within 5 minute walking distance of school? Well, first of all, it's not relevant to board games, so that might be one answer. The other thing is that 5 minutes walking distance depends on how fast you walk. So I would say it depends on walking speed. So should ask for distance in kilometres, etc. And question 2, how often do you play board games? Well, it depends over what time period. Is it over a year? Is it over your whole life? So assuming this could be over your whole life, everybody's probably played a board game more than 10 times. So does not state over what time period. The survey was carried out by leaving copies of the questionnaire in a local supermarket. Give one criticism of how the survey was carried out. So it's only carried out in one location. So you're asking school children to answer a survey that they'll find in a supermarket. So only children who go to that supermarket can answer it. Right, Maria and Hugh share a prize of £2,700 in the ratio of 4 to 5 respectively. Maria decides to donate 24% of her share of the prize money to charity. Hugh decides to give the same amount of the money to as Mary to charity. What fraction of Hugh's share of prize money was given to charity? Express your answer in the simplest form. So this is where these questions overlap with the higher tier paper. So first of all, we can say that 4 to the ratio of 5 is equal to 9. Therefore, Mary's portion is equal to 2,700 divided by 9 times by 4. So 9 goes into 9 once, 9 goes into 77 3 times. So we got 300 times 4, which is £1,200. She then gives 24% of 1,200 to charity. So this is the equivalent of 24 over 100 times by 1,200. So these two zeros will cancel with those two zeros. 24 is 2 times 12. So we got 12 times 12, which is 24, times 2, which is £288. So Hugh's portion is what's remaining. So that's 2,700 minus 1,200, which is 1,500. Hugh's charity will be equal to the amount he's going to give. So he's going to give the same amount as Mary, which is 288 over 1,500. So both of these are divisible by 3. So that would give 500 on the bottom. There's 100 3's in 300, but we have to take 4 off because we have to take 12 off, which will give us 96. Both of these are divisible by 4. So there are 25 4's in 100, which means in 96 there's 1 less 4, which gives you 24. And therefore there's 25 times 5 4's in 500, which is 125. So that's the fraction in its simplest form, because we can't divide by 2, 5, 4, 6, because they're not common. The scatter diagram shows the length and width of some television remotes. 2 of the remotes have the same width. Write down the width of these 2 remotes. So we look at the width axes, which is Y, and we look for 2 dots which are level, which is at 3.9 centimeters. And their lengths are 17.7. So we're coming down here, and 18.5. Consider the remote with a width of 4.5. Write down the ratio of its widths to the remote's length. Give your answer in the simplest form. So we know the width is going to be 4.5, and that's going to be this one, which has a width of 17.5. So both of these are divisible by 0.5. So that's going to give a ratio of 9 to 35. And I don't think that can be simplified anymore, because 9 is only divisible by 9, 3 and 1. and 35 isn't divisible by 3 or 9. How is it best to describe the correlation seen in the scatter graph? So it's negatively correlated, because it's going down. So our line of best fit would be going down. So negative correlation. Draw a line of best fit on the graph. I'll sort of just already sketched that in. So in an exam you make this a bit more cleaner. Is it certain that another television remote of 18.5 will have a width in the range of 3 to 4 centimetres? So 18.5. So we could argue yes, because the line of best fit would indicate that. Or we could argue no, because we don't actually know if there's any causality between these. So I'm going to say no, because no indication of causality. So the data would suggest that there is a link, but we can't be absolutely certain because it is just a scatter graph. We'd need more data. We'd actually need to measure every single remote control there is in the world to do that. Hestia and Walt hire a canal boat in Llangollen for their holiday. Hestia records the distance along the canal from Llangollen between 8 a.m. and 4 p.m. And this is shown in the travelled graph below. During the day, Hestia and Walt make a stop by the side of the canal. What time did Hestia and Walter stop at the side of the canal? So this is when the distance stops moving. So the first time they stop moving is here, which is at 11 a.m. Between what times were Hestia and Walt travelling the fastest? Circle your answer. So this is where the graph is steepest, which is this section here. So it's going to be between 8 and 8:30, which is a possible answer. What is the total distance Hestia travelled in the boat between 8 a.m. and 4 p.m? Circle your answer. So they travelled out 9 kilometres, and then they turned around and started heading back, and they stopped 3 kilometres before Llangollen on their way back. So this means we have 9 plus 9 minus 3, which is 9 plus 6, which is 15. Okay, Hestia and Walt visit Chirk Castle. Which is the best estimate for the bearing of Llangollen from Chirk Castle? So Chirk Castle is here. We take the bearing all the way around in a clockwise direction from the north. So this is above 270. So it's going to be either 300 or 340. That looks to me more like 300. We could just check that with a protractor in the exam. The direct straight line distance between Llangollen and the Pontysello aqueduct is 5.6 kilometres. On the map, the distance is 5.6 centimetres. What is the scale of the map? So there is 100 centimetres in a metre and 1,000 metres in a kilometre. So that is 1 to 100,000. The aqueduct was built to carry the Llangollen Canal over the valley. The following facts about the section of the canal over the aqueduct were found on the internet. It is a rectangular uniform cross section. It is a length of 300 metres. It holds 1,500,000 litres of water. It takes 2 hours to drain. The section of canal over the aqueduct is to be drained. Calculate the number of litres of water that is drained from the section of the canal per minute. You may assume the water drains at a constant rate. Okay, so we got 2 hours. That's equal to 120 minutes. So we have to convert to minutes. So we're going to divide 1 million. I think I need to recalibrate this so the pen actually starts in the right place. So 1,500,000 all over 120. So we can cancel that 0 with that 0. So we've got 12 into 150,000. Well, 12 goes into 15 once, remainder 3. 12 goes into 32 times, remainder 6. 12 goes into 65 times, and we've got a couple of zeros left. So 12 goes into each of those 0 times. So it is going to be 12,500 litres per minute. Calculate the area of the canal's uniform cross section. Give you answer in centimetres cubed. Well, first of all, we have the volume of water in litres. So we need to do 1,500,000 litres is equal to, so we need to convert this to centimetres cubed to get the volume in centimetres cubed to be able to work back to again centimetres squared for the area. So we're going to times it by 1,000 because there is 1,000 centimetres cubed in a litre. So we have to add another 3 zeros onto this. Okay, and then we have to do 300 metres is equal to 300 times by 100, because there's 100 centimetres in a litre. So that's it in centimetres of length. So in order to find out what the cross section is, so a volume, if you divide by the length, will give you the cross-sectional area. That's the formula on the front of the paper. So if we divide these two, we can cancel those 2 zeros with those 2 zeros, those 2 zeros with those 2 zeros. 3 goes into 3 once, 3 goes into 15 5 times. So we end up with 5,000 2, 3, 4, 50,000 centimetres squared. Right, a jar contains 300 grams of chocolate spread. In the spread, there's 58% of the mass is pure sugar, 1/8 of the mass is cocoa. The mass of milk powder is 4/5 of the mass of cocoa. The remaining of the 300 grams is palm oil. Calculate the percentage of palm oil in the spread. So first of all, we can convert some of these into percentages. So we have 100% is going to be all of it. So we can do 100 minus 58% is equal to 42%. And then 1/8 is equal to, well, a quarter is 25%. So this is half of that. So it is equal to 12.5%. So we can do 42 minus 12%. So that's going to take us down to 29.5%. And then we're going to look for 4/5 of 12.5%. So times 12.5 by 4 gives you 50 over 5, which is equal to 10%. Therefore, we can do 29.5% minus 10% is equal to 19.5% is palm oil. A different jar contains 840 grams of chocolate spread. The label on the jar says offer includes 20% extra chocolate spread for free. How many grams of chocolate spread did the jar contain before the offer? So increase by 20% can be written as 1.2 because 20% is 0.2, and if we're increasing, we can put a 1 before it. Therefore, we have 1.2 times some unknown value, which is the original before, or the value before, is equal to 840. Therefore, we have 84 over 1.2. Well, that looks like 12. So that would give 84 divided by 12 is 7. But we've moved the decimal point from the 1 to make it to 12 from 1.2. So we have to add a 0. And there's an extra 0 on the 840. So the original weight of the jar was 700 grams. Deva Design Services employs 60 people. Employees were asked to log on to their computer by 9 a.m. The number of employees logged on was recorded every 10 seconds from 9 a.m. The results are displayed in the cumulative frequency diagram below. Use the cumulative frequency diagram to estimate the median time taken. So this is the time it takes for the middle person, which in the case of 70 people is 35, which is here, to log on, which is there. So that's coming down at 45 seconds. Dava Design Services has a policy that states the following. 90% of employees must be logged onto their computer by 9:01 a.m. Show that this policy was met on Tuesday. So if we find 90% of 70, that is equal to 90 over 100 times by 70. So those cancel, and that will give 63. So we're looking for the 63rd person. Oh, one sec, we've made a mistake here because we're not. It's not 70 people. There's 60 people in the company. So that means we're actually looking for the 30th person, which is there. So it's actually 40 seconds. The one above, and this is going to be 60 times 9, which is the 54th person. So we're going to look for the 54th person, which is about there, which is at about 59 seconds. So the 54th person logged on at 9:00 and 54 seconds. Therefore, policy met. Right, Annan Frame is a company that employs 360 people. 6 of these people were selected to discuss a change to their company logo. The manager has decided to use a systematic sampling method. He has numbered list of all 360 people. When using the systematic sampling, where should the manager start? So we've either got the 60th name on the list, at a randomly chosen name on the list, first person on the list, last person in the list, a name by a multiple of 60. So the answer is a random chosen name. The manager actually starts by selecting the fourth person in the list. Complete the table below to give the positions of the 6 people who will be selected. So we have to work out how many 6s are in 360. So there's 1 6 in 6. There are 6 6s in 36. So there is 60 6s in 360. So we're going to go up in 60 people. So this will give 64, 124, 184, 244 and 304th person. David works in a call centre. On Monday he made 200 phone calls. He recorded the length of the time he spent on each phone call. David noted that the following about the time spent on each phone call. The greatest time was 2 minutes 10. The range of the times was 2 minutes. The median time was 84 seconds. The upper quartile was 108 seconds. And the interquartile range was 68. And the first question is to complete the box and whisker diagram. So first of all, the median was 84. So this is going up in 2s because there are 10 boxes between 80 and 100. So I need to do 2 boxes more than 80. The greatest time was 2 minutes 10, so this is 130 seconds, which is there. The range was 2 minutes, which means we've got 130 minus 120, so that's 10. So we need to put a line at 10. The upper quartile was 108, so again we need 4 boxes past 100, which is there, which means we can now put in the line across there. And now we need to find the lower quartile, which is 108 minus 68, which is 40, which is there. So we can join this line up, and then to complete the box goes between the upper quartile and the lower quartile, and the median should be in the middle. David sets a target. He has to complete half his phone calls in less than 1 minute 30. By how many seconds did David beat his target? Well, he did half of them so the median was 84. So the difference between 1 min 30 is equal to 90 seconds. This gives 90 minus 84, which is 6. So we got 6 seconds. On Monday, how many of David's phone calls lasted less than 108 seconds? So this was the upper quartile, so this is the 75th percentage point. So we got 75% of 200. Therefore, this is 75 over 100 times by 200. Those zeros will cancel, so we have 75 times 2, which is 150. And that completes the paper.